Okay, so it's not 6 o'clock. Welcome everybody. A little bit late, but we actually got like 5 hours to do this before the France-Spain game, so we're gonna get locked in. We're gonna be absolutely locked in for this. So yeah, let's go. Uh, how do you use this again? Where's the eraser? What is it? Nope. This is the pen. This is the pencil. This is the eraser. Okay.
Hello, my name is Mr. Asprey. Question number one, and we have a g of x.
This seems pretty easy. So number one is a bit too thick. Yeah, it's better. One is this. Given that this is, let's see how he does it first.
Is equal to this cubic expression, where k is a constant. It says given that x minus 3 is a factor of g of x, find the value of k. Okay, so we're going to use the factor theorem here, and the factor theorem states that if we know that x minus a is a factor of, let's say, f of x, then it is implied, and implied by, that f of a will equal 0. So in this case, we've got x minus 3 is a factor of g of x, so that tells us that g of 3 should equal 0. And to find g of 3, we just substitute 3 into this function here. So I'm going to write 3 lots of x, I'm going to replace with 3 cubed minus 20, 3 squared plus, and let's just expand this out, so k times x, but x is 3, so that's just going to be 3k. And then 17 times x, when x is 3, is going to give me 17 times 3, which is 51, and then plus k, and we said that equals 0. Okay, let's evaluate this. So 3 cubed is 27 times k minus question. A few marks. Let's move on for
Okay.
100.
Seems pretty easy. Seems pretty straightforward. So, this is the function. Whoa. This is the function. 3x cubed minus 20x squared plus k plus 17x plus k. Can I make this a little bigger? Or is this just how it is? Just small, medium, large. Okay. And what? Given that x minus 3 is a factor, find the value of k. X minus 3 is right then. 3 is x minus 20 squared plus 3 k plus 17 3 plus k equals 0. I think this was, yeah, cool. And then obviously just base because it's huge. 3 cubed minus 20 squared. So minus 99 plus 17 minus 48. So 4k equals 48, which means that k equals 12. Boom. That's number one. That's number one. Much space left? Okay, so that's easy. Number two.
108 question. Okay, question.
Ooh, disgusting. Binary expansion, bro. You. Ew, man. That's nasty. Okay, ascending powers of x, the first four terms of binary expansion. You do it.
2, it says find in ascending powers of x the first 4 terms of this binomial expansion. So first thing to notice is that we have a fractional power, which means we're going to need to use the formula for the binomial expansion that we can use with any given power. That is in our formula book, and it looks exactly like this. Okay, so we're going to use that. Next thing to note is that the formula from the formula booklet here needs to have 1 as the constant term inside the bracket. We already have that, so that's good. It means we're not going to need to take out a factor. Okay, so we can just go really.
Loki, I might be able to do this by myself. I could definitely just do this by myself. I need the oh, he's got out form. Okay. Okay, number two. We got so the 1 a half times 9x plus okay, so half minus 1 over 2 factor 9 squared. The first three. That's 3. Okay. It does not scroll. That's fine. Plus half. Let's figure out to do this part. Half minus 1 half minus 2 over 3 factorial. So Yeah, and then x minus cubed. So what's this? First one's 1. Next one is going to be 9x over 2. The next one is going to be see its first bit 0.5 minus 9 over 2 factorial, and then times 8 so this will be minus 81 over 8x squared, and then 0.5 minus 1 0.5 minus 2. That's one. 0.5 0.5 minus 1 0.5 minus 2 3 factorial. That's 1/16 times 9 cubed plus 729 over 16x cubed. That's the first 4 terms in its simplest form. How do you simplify that? Chat, how do you simplify that? Chat, do any of you know how to simplify that? How do you simplify that, chat? I don't know how to simplify it. Like if you times everything by 16, there's no fractions. The reasons why x equals minus 2 over 9 should not be used to extension. To find an approximation of 2 through 3. Well, because you can't use minus 2 over 9 because it is too small. Too small. Right, did we get this part right?
And so there's going to be a minus. Okay.
I did not.
Perfect.
Okay. I made this mistake last time. Okay. So it was never 9x, it was minus 9x. It's always been minus. It has always been minus 9x. Okay, cool. Okay. Every single time, bro. Easy to type. This is where I lose marks. Just signs. Anyway. The reason why minus 2 over 9 should not be used in expansion. Well, I can know what that is. because it doesn't meet like x. So x then so it's that 9x. So how'd it go? How'd it go? Let's figure this out. So it's gonna be a 1, which means that x has to be 1/9. So it has to be smaller. The modulus has to be smaller than 1/9. -2/9 bigger than -1/9 -2/9 no work. Right? Yeah, do that part right. I'm being dumb again. I am. It's minus. Holy. So, oh my days. So it's -1/9. Has to be smaller than -1/9. Ah, bro.
So
Yeah, man.
-2/9 is
Oh, so
outside of the
we ignore,
range of validity.
we ignore it now.
Outside of range
What on earth?
validity. X needs to be less than -9. Needs to always be less than 1. So, well, the modulus is going to take care of the minus sign there. And if we divide through by, if we're going to divide through by 9, we're going to get that the modulus of x needs to be less than 1/9.
Mm.
Okay. So in this case, x equals -2/9 is outside of the range of validity. Outside of range of validity. I think I'm saying that right.
That makes no sense.
Okay, perfect. Yes, so because
Okay, anyway.
yeah, so the smallest x can be. So basically, what this means is when the modulus is less than a ninth, it means that x needs to be in between -1/9 and +1/9. So -2/9 is too negative here. It's outside of this range that we need. So therefore, it's not going to be used for for an approximation.
Yeah.
Question 3, we've got a function here, and
Pardon? that's fucking.
X is given in radians, which is important, as you can see from the domain over here.
Given the question fx equals 0, there. Who's this? Oh, Newton Raphson. Okay. Look, can you and Lee can't remember how to do Newton Raphson? But we start with a function. This is how we start the question. Lay the groundwork. Lay the groundwork. And then okay, so this is the okay. That's where it's valid. Show that alpha at the single root. Given that this equation has a single root. Okay. Right. Show that it lies. Okay, to Newton Raphson. Okay, no, this is change line. So, okay, so what we're gonna do 3.6 plus tan half 3.6 gives us in radians. Should I be in radians? I should. Gives us minus 0.6. And we're looking for a plus in the second one. So 3.7 plus tan half 3.7 equals 0.2 and 1 line change of sign. Okay, that's 2 marks. Find the derivative. So you need to differentiate. So x plus tan half x fx 1 plus tan. What is tan differentiate? Big brain, big brain, big brain. Sec squared. So it's going to be half sec squared half x. That's it differentiated. Okay. C. Using 3.7 as approximation. Apply Newton-Raphson to obtain a second approximation for A. Okay. So Newton-Raphson. So it's 3.7. Using 3.7 plus. Right. It's the opposite of a because normally it's differentiation on the top, original on the bottom. But we're going to have original on the top and differentiation on the bottom. Is that how it goes? Just tell me, bro. I ain't got time to be wrong. I ain't got time.
F and rule multiply. Apply the Newton with 3.7.
Original on the top, differentiation on the bottom. Yes, that's correct. That's correct. That's correct. Okay, cool. So it's going to be so, and it's minus. It's always been minus. It's always been minus. It will always be minus. Okay, and then original on the top, differentiation on the bottom. So we have original on top, which is x. Okay, plus tan half x over 1 plus half sec squared half x. And then this would actually be x. Right, and then you just slip it in. So it turns into 3.7. 3.7 plus tan half 3.7 over 1 plus half sec squared half 3.7, which gives me what? How do I do sec squared on a calculator? Is it like inverse of cos squared? How do you do cos squared? I don't know. Monster, how can I feel? Okay, I'm on time, but I'm gonna do 1 over cos. I guess you're gonna close it and then do that. Probably. And then square it. Okay. And then that gives me 3.67. How many times does it get?
As we were told, okay, so it says using 3.7 as a
First approximation of polynomial method. Once. 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 Okay. We're supposed to do this once. 3 different places. 3.672. Boom. Next. Tell me I'm right. Tell me I'm right. Tell me I'm right. Tell me I'm correct. Thank you. Thank you. Hold on. Next.
Okay, question number.
Next. Okay, we're doing okay on time. We're doing okay on time. Oh, we got line paper this time. Once there, how can I feel? Interest lie here. Okay, differential from first principles. Show that dy dx equals, okay. I actually know how to do this. So it's there's an equation sheet. Can I get the equation? Are you gonna put it up? Tell me pulls up the equation.
Four differentiation. So we can write. So we go to our formula booklet.
Okay. You pulled up the cool. Yes. So it goes like this. So it'll be x plus h squared minus x squared over h. Right. And then that just turns into x squared plus 2xh plus h squared minus x squared over h. They cancel. So you're left with h squared plus 2xh over h. So then you're left with h plus 2x. And then when h goes to 0, the h will cancel, so you just have 2x. Okay, that's nice. dy dx equals 2x. That's a simple one. That's a simple one.
It's given in the formula book.
5. Look how we've done 17 minutes of the video. There's an hour 56 left. Going. Okay. Oh, we're on the evil one now. We're on the evil one. 5. Okay, show like this. Oh, I did this yesterday using algebra. Okay, this is differentiation. So 2x minus 3 over x squared plus 4. And then this is u, this is v, because the thing is goes so it's over v squared, right? And then it's v du dx minus u dv dx, right? And then so that would be what, 2? Is this right? Again, we don't have time to be wrong.
Question 5. It says the function is x squared.
Cool. So it should be 2, because that's du dx is 2. 2 x squared plus 4 minus 2x Really? That's hideous. Memento. Yeah, that's right, that's right. So 2x minus over x squared plus 4 squared. Now, this turns into 2x squared plus 8 minus 4x squared minus 6x. No, it does not. Minus 4x squared plus 6x. Cool. Then 2x minus 4x equals minus 2x. So it should be minus 2x squared plus 6x plus 8. Cool. Over x squared plus 4. Hence using algebra, find the values of x which f is decreasing. You must show each definite workings out. Find the values of x where f is decreasing, so the gradient is decreasing, which is what we just found. So this is decreasing, so that means this is less than 0. This is always positive. So for this to be negative, this has to be negative, which means minus 2x squared plus 6x plus 8 has to be less than 0. I use my calculator. It's number 2. Can't be equal to, right? Minus 2, 6, 8. So we get x must be greater than minus 1 union x has to be greater than 4. X has to be smaller than minus 1. X has to be greater than 4. Okay. Is that what we got? Is that what we got? Is that what we got?
This part here. So the x values that give us those parts of the graph are when x is less than minus 1 or when x is greater than 4. So our answer is, does it ask for set notation? No, it doesn't ask for set notation, it just says find the values. But anyway, I'm just going to give it as a set. I'm going to say that x needs to be less than minus 1, union x needs to be greater than 4. And that should do the job.
Next.
Perfect. Question 6, and we have...
Okay, we are flying through this. We're flying through this. Okay, question 6. Oh no, 39 minutes. Oh, wait. On question 6. We're 39 minutes in. We're on question 6. Deep down, guys. Deep down. Figure 1 shows a sketch of the graph of the equation y equals. Okay. So you have y equals 3x minus 2 plus 5. Find the coordinates of P. Okay, he big brained this before, so we know that that point P is one of the two equations. How did he big brain it? He big brained it last time. I can't remember how he big brained it. Tell me, how'd you big brain it, bro?
Have a sketch of a modulus function. We get given the equation. It says that the vertex
No, I'm gonna figure it out. I'm gonna figure it out.
of the
No.
graph is at point P. So that's like the minimum point of this modulus function. Now, in order to minimize the modulus function, well, this part can only be positive or 0. So the smallest possible thing we can have is 0, and the value of x which makes that 0 is 2. So we know then for part A, we want x to equal 2 to get to the minimum point. And when that is 0, then we've just got y is equal to 0 plus 5, so therefore y is equal to 5 at that point. Which means that the point P is at 2, 5.
What?
Which is quite nice. So x to equal 2 to get to the minimum. So we know then for part A, we want x to equal 2 to get to the minimum point. And when that is 0, then we've just got y is equal to 0 plus 5, so therefore y is equal to 5 at that point. Which we know the value of x which makes that 0 can only be positive or 0. So the smallest possible thing we can have is 0, and the value of x which makes that 0 is 2.
That's the smallest possible x value. What? What? Yeah, the smallest possible x value is when it's 0. Is when x equals 0. So we've made x. No, we've made x equal 2. What's going on? X isn't 0. X. Because that's when the modulus is the smallest. The minimum point. Hold on. The minimum point is when the modulus is the smallest. Okay, why? Broski. So, when the modulus is the smallest, it's a minimum point. Right, and then I don't understand. I don't understand, man. I don't understand. Why? I need to work on my transformations, bro. How? So, what's that? Bro. So then what's... So you're telling me that plus 5 isn't the y-intercept? So I can't trust modulus functions to give me the y-intercept, basically. How? Because when x equals 0, Yeah, if that's 0, then 0 minus 2, which is minus 2, and then, okay, so how do you find the y-intercept? Well, okay. Oh, oh my days. Okay, so is x is 2. It's like a rule. Like this is just another rule to learn. There's no actual intuitive understanding behind this whatsoever. It's just a rule that I have to learn. Is that they just meet when the modulus is 0. Is that it? When the modulus part is 0, then I guess that makes sense for them to meet because they'd be identical. Get rid of this bit, it's just, you get what I'm trying to say? Just 5. So for them to meet, okay, I guess that makes more sense. If we're talking from like for the two lines to meet, this is when this is 0. That makes sense to me. So I guess that is the minimum point. Okay, okay, yeah, okay, good. Took me a while. Okay, so x will have to equal 2, y have to equal to 2, if that's 0, then I'll just be 5. I'm writing this way too big. Why am I writing so big? Okay. Wow, that was crazy. Solve the equation. Okay. 16 minus 4x equals 3. X minus 2 plus 5. Interesting. I think I'll put everything to one side. I think I'll put everything to one side to make it 3x. Oh, what's this? X minus 2 plus 5 plus 4x. And then we're minusing 16 equals 0. So 3x minus 2 plus 4x minus 11 equals 0. And we just gotta do both sides of this. Yeah, you just gotta do both sides. Make this just 3 and then 3x minus 6 plus 4x minus 11 equals 0. and it's minus 3x plus 6 plus 4x minus 11 equals 0. So these are two answers we got on the first one. 4x, 7x minus, so minus 6 minus 11 gives us minus 5, so 7x. 7x minus 17. So in the first one, x equals 17 over 7. And then the second one, we got minus 3x plus 4x is x. And then minus 5. Sorry, 5. X equals 5. Crazy. So we got x equals 5 on the second one. Now, can it be both of them? No. I don't know why I'm saying that. We're going to put it both in the calculator, see what happens. So 16 minus 4, 5. Oh, wait, just do the way around. So 3, and then how do you do modulus on this thing? How do you do modulus? How do you do modulus? How do you do modulus? There's a way, but I don't know how. Is it absolute? It is. Boom. Okay. 3, and then let's try 5 minus 2 plus 4, 5 minus 11. Does that equal 0? No. Okay, let's try 17 over 2. 17 over 7. 17 over 7. 0. Boom. This is the answer. And the reason why it's not this one is because it just doesn't work. Why doesn't it work? Because it just doesn't.
So we know then for part A.
Oh, and then part C, find the ranges of values of k. It's just some crazy. So you have to go from 4 to 5, which is, it has to have a gradient of half. It does have a gradient of at least a half, right? And that's the gradient, bro. Oh my days. I'm off my head. K has to be bigger than a half, right? And K has to be smaller than. Oh, so yeah, that should be parallel. So what's the Was that 3? What's the gradient of that? It's just 3x minus 6. Yeah, so it's 3. So it's smaller than 3. Boom. Boom, boom, boom.
Smallest possible thing we can have is
Okay,
vertex.
right.
The modular 8 now, that the range of values of k
Right.
are such that, I'll give it in.
Did I get it right?
Also important to note, it can't equal
Boom, boom, boom. Next.
because when it equals a half, it only cuts at the vertex, which is 1 point, so that's no good. And when it equals 3, it's parallel, so again, that's no good. It only intersects once. So that is our final answer.
7. Next. Oh no.
Okay, we have for number 7 a cylindrical tank.
Okay, it's time for the big boys. It's time for the big boys, It's time for the big boys. These ones are terrifying for me because I hate, I really do not like differential equations. And I'm going to have to be doing so many more differential equations in the future. I do not look forward to it. However, I do look forward to finishing it. So, okay. Alright. So, let's actually read the question. 1.5 meters. Initially, it's full of water. The water starts to leak. Oh. Showing that h equals a, so we're just basically okay. Okay. So we do this like this, right? We times, yes, that makes sense. So this it gets a dt, and then on this side it'd be a 1. So this is everything's times by 1, and then you technically have to put the 1 over 1, but 1 over 1 is 1, so it just turns into the integral of 1 with respect to h equals the integral of minus 0.12 e to the power of negative 0.2 t with respect to t. All right. Oh, I need more paper. How do I make more paper? I need more. Back page. Current template. Yeah. I need a lot more pages. Can I just like add like infinite amount of these pages? Okay. Okay. I think we're good on pages. Okay. So what that means is, so this side just turns into h, right? Equals, that's that differential, integrated. Now to integrate this, not as easy because it's in e, and then is it the same as Hmm. 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 How does he do it? Just tell me, bro.
Height 1.8 is in this equation out here. And then we're just going to integrate. Okay, so when we integrate the same, but we just divide by the derivative of the input. So we need to divide by
The derivative of the input, bro. So e to the k x. You differentiate that, you get k e to the kx, right? So you integrate e minus 0.2 t minus, hold on. So wouldn't it be like 0.2? So should I divide it by 0.2 minus 0.2? Yes, I should. I should. So it should be minus 0.12 divided by minus 0.2 to give me 3 over 5 e to minus 0.2 t. Boom. Okay, now it's finished, right? That's game. Certainly seems like game to me. Yeah, I think it's game. So we're just gonna divide it by 3 over 5. So that should give us 5. Whoa, that's a crazy 5. 5 over 3h equals e to the negative 0.2 t. So what we're going to do, we're going to ln it. So it's going to be ln 5 over 3h equals minus 0.2 t. What's this supposed to look like? Going back. Applause. I came for the applause. Was came for the applause. Was 5 over 3h equals minus 0.2 t. What's this supposed to look like? What is it supposed to look like then? What's it supposed? What should it look? What should it look like? Why is this tweaking? What's going on? What is going on? What's going on? What's it look like? Control Shift Windows B. Yeah. Walk in. Walk in.
y.
It's actually still tweaking.
This differential equation.
Okay, it's supposed to be h and then A. Oh my days. Okay, we actually forgot the plus C. Plus C. So we forgot the plus C. So it should be okay. You actually did definitely forget the plus C. Okay, so it's supposed to look like that. How did you do it? Just tell me.
Equation where t is in hours. That's important. That might be useful.
Just tell me.
And this is equal to minus of integral. So and of course we're going to get a plus c. I need to divide it minus 0.2 t plus c.
Just tell me, bro.
Is that what they want? Right. So we found a. That's the 3/5. B, the constant of integration. We need an initial, or we need a bit of information in order to find that, and that's going to come from.
Oh. Ah. Ah. Okay. All right. So I'm guessing that's the 15, 115. Is it 150 or 15? 15. Yeah, when it's 0. So h equals 15 when t equals 0. So 15 equals e to the power of 0 is what? Just 1. Anything to the power of 0 is 1. So it's 3 to the 5. So I mean 3/5 plus c, which basically means c equals like 14 point. Even this 3/5. 14.4 basically. Cool.
Right here. So we need to sub that in.
Find the time taken for the depth of the water to decrease to 1.2 meters. Okay. The time taken for the water to decrease to 1.2 meters. So that means h equals 1.2. 1.2, right? Wow, that's amazing. Okay, we can just skip that. We can just do 1.2 equals 3/5 e minus 0.2 t plus 14.4. That seems kind of crazy.
And that's going to allow us to find that missing constant. It's c over c. So if you're r plus 0.9.
Where did you get that? Oh. It's not 15. It was 1.5. Okay. Okay. Okey-doke. Zero, 12.9. No problem, no problem. Isn't this just risky? What are you asking me right now? Okay, so 0.3 over 0.6 is like, what, a half. So we have 0.5 equals e to the minus 0.2t. So that means ln 0.5 equals minus 0.2t. Ln 0.5 over minus 0.2 equals t. T equals wow, that's fast. 3.466 seconds. Am I right? I got time to be wrong.
Hours and minutes.
Good. I'm on a good banana. Feeling good today. Okay, cool. I'll give your answer in hours and minutes to the nearest minute. Wait. What is time? Time is hours. Okay. This is hours, which means that this is 3 hours and 3 hours and what's 60 times 0.466, like 27, not 28 minutes, 3 hours and 28 minutes. Cool. In the long term, the water level in the tank falls to the same height as the hole. Find, according to the model, the height of the hole at the bottom of the tank. Okay. Yes. Okay, so I'm guessing it never reaches 0, which is something I should have figured out, but I didn't. Why doesn't it reach 0? If the time's infinite, if the time is infinite, so if I have 3 over 5 e to the power of minus 0.2, 1 big number, plus 0.9, it's going to give me 9 over 10. 0.9. Why? Why isn't it infinite? Okay, so the height is 0.9. I'm guessing that is because I have 0.9 now. Because when that gets really big, when t gets really big, this turns to 0 somehow. How on earth? If it's minus, let's do some e to the power of minus 100 equals what? What are we talking about, bro? What? 3 over 5 e to the power of minus 100. Crazy number. What? Why does it? Why does it get smaller? Oh, it just gets really small. It gets really small. It gets really small. Okay. Okay, well, it's 0.9. I want to hear his explanation.
Just write it out here. So dh by dt is equal to minus 0.12 e to the minus 0.2t. So we're going to separate the variables here. We're just going to multiply both sides by dt to get this like so. And then we're just going to integrate both sides.
One of these other questions are.
Like
what is
so.
this? This
okay,
must be
so
terrible.
the integral of dh is just h.
I'll be fine.
And here, when we integrate an e function, we just keep the e function exactly 2. And of course, we're going to get a plus eventually because that's pretty close to 28. Okay, log according to the model. I'm just going to write that down again. Actually, what we're going to do is go to a large number, to a large minus number, should I say, because it's going to be 0.2 times by a large number, but there's that minus there. So where e to a large negative number is going to tend to 0. So therefore, this is a large number, but there's that minus there.
Anything to a large negative number tends to 0. 2 to the power of negative 100. Yeah, that'll do. It's 0. So anything to the power of a large. Why? Why? Okay, 2 to the power of minus. Okay, what's 2 to the power of minus 2? 0.25. Where does that come from? What is actually going on? It's 1 over 2 squared. Yes, okay. So essentially we're doing 1 over e to the power of big number gives you really small number. Okay. 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 Alright. Okay, I can live with that. I can live with it. I can live with that.
So where e to a large negative number is going to tend to 0. So therefore, this is just going to give us 0.9. And that's meters. And that's it. That's the final answer for that particular question. Again, you could just sub in a large number into your calculator into the formula and you'll get 0.9. Question 8, we've got the functions f and g are defined as follows. Find f of g of 2. So a composite function means you put 2.
What is this? 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 I said, what is this? I said, what is this? No. Wait. Yeah, not bad. Not bad. Yeah, it's not bad. It's not bad. It's not bad. Let's get it. Okay. Um. 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 Bruh. Okay. Okay. F too big. FGX. FGX. Yes. Oh, it's not even X2. So, okay. Let's find FGX first. Okay, so it's 4 minus 3. And then it's 5 over 2x minus 9 squared. So that's 4. Bro, you're charging. You're literally charging, bro. Okay. So it's 4 minus. Okay, this is a tough one. Does the 3. No. No. No, it doesn't. 3, 25 over 2x minus 9 squared, which is 4x squared. 18x minus 18x. So minus 36x plus 81. So we've got 4 minus 3, 25 over 4x squared minus 36x plus 81. What's 3 times 25? 75. So 4 minus 75 over 4x squared minus 36x plus 81. Now we just sub in 2. So we get, I'm just going to calculate it. 4 minus 75 over 4, 2 squared minus 36, 2 plus 81 equals 1. It's 1.
Into G and then to F. It's inverse function for Y.
Yeah, told you. What to say. Like, how does he just do Like he just does that, bro. You serious? Do that in 5 seconds. Oh my days, how did he do that? How did he do that? How did he do? How to expand? How to expand, bro? I had to do all this, bro. What? Okay, hold on.
Two lots of 2 minus 9, which is the same as 5 over 4 minus 9 is minus 5, so that's just going to give us minus 1. Okay, so now we put that value into f. So if for us to find f of g of 2, we just put minus 1 into f, because that's what g of 2 is. Okay, so f is 4 minus 3x squared. So we're doing 4 minus 3.
Wow. Wow. That's wrong, bro. That's wrong. That's really wrong, bro. That was really, really wrong. I feel wrong. I feel done dirty, bro. I feel betrayed. I've been wronged. They have wronged me. Okay, this is cool. I mean, I got the right answer anyway, so it doesn't actually matter. The function h is defined by no. Okay, find g minus 1. Okay, g minus 1 is okay. So y equals 5 over 2x minus 9. Swap it to make it x equals 5 over 2y minus 9, and now make it normal again, so that will give us how should I approach this? We can do 2y minus 9 equals 5 over x. Alright. 2y equals 5 over x plus 9. Y equals 5 over 2x plus 9 over 2. How's that 3 marks? It's like the easiest 3 marks I've ever seen.
Minus 9, which is the same as 5 for y. Like so. 9x over 2x. And then we're going to write g to the minus 1 of x is equal to this. 5 plus 9x over 2x. Okay, but
what? What? Is this the same thing? It probably is. 5 over 2 plus 9 over 2. 23 over 4. Yeah, it's the same thing. So we're correct. It's kind of scary how I can't notice that it's the same thing, but we made it.
And it's a big one. You have to state the domain when you create a new function. So I've created an inverse function here. We have to state the domain.
What are you talking about?
Now, I can see straight away that the domain is going to be that we can't divide by 0, because so therefore x can't be 0. So I'm going to write here, comma, x can't be 0. Also, another way of doing it is that the domain of the inverse is the same as the range of the original function. Okay, and this function here can spit out any value at all. The only value it can't spit out is 0. Because if you have 5 divided by a variable like this, and if you wanted that to be 0, there's just no x value that can make it. You multiply up and it would just make nonsense. It'd be 5 equals 0. So 0 is the only thing which cannot come out of this function. So therefore, it's the only thing that cannot go in to the inverse function. Brilliant. Okay, now we're asked to find g of f of x, which means I pick up the whole of f of x and I put it into g. Okay, so let's do that. I'm just going to box this up. That's the final answer. And we're going to go down here and we're going to try and do g of f of x. Can't spit out.
So once find g f of x. Okay. You want g f of x. I'll give you g f of x. Is he gonna do some? No, he's not. You can't. You have to do it with me. Okay. So it's gonna be 5 over 2, and then x is gonna be 4 minus 3 x squared minus 9. I got some 5 down to make it 5 over 8 minus 6 x squared minus 9. So 8 minus 9. So 8 minus 9. It's minus 1. Minus 1 minus 6 x squared. This is pretty simplified. Is it not? I think it's been pretty simplified. He's gonna tell me otherwise though.
Is 0. Because if you have, okay, so let's do that. Input now as the for that composite function.
Boom. Okay. What else we got? What's up? Deduce the range. Still don't understand what range is. But from his description, range is, well, can this be 0? 5 over something. Basically no. 5 over nothing. Nothing you can put 5 over creates 0. So can't be 0. It's not x, it can't be 0. But y, and it can't be I don't know. That's all I got.
We then do that transpose where we swap the x for y, which inverts the function, and then -1. So that doesn't change the function, it just writes it slightly differently. So we're going to get this. Okay, now I've done this because now hopefully it's easier to see that the output of this function will always be negative.
Bruh. How did you, how? But if that x is -3, well, oh, but then it's squared. It's squared, so it will be positive. So x has to be, this has to be positive. So yeah, so it could be negative. So also we have y cannot be, so it has to be smaller than 0. Right. So is that the range?
Because you've got a minus here, so the top's definitely negative, and the bottom is always going to be positive, because x squared always gives out positive values, so we're always going to get positive on the bottom, so overall we're going to get negative. Okay, so we know all of our values are going to be negative. Now, what's the biggest value it could possibly be then? Perhaps it could be 0. Well, no, it can't be 0. We can't solve this equation. There's no value of x that you can put at the bottom here that's going to make this give out 0. If you can't divide 5 or -5 by something and get 0, it just doesn't work. Okay, so we know it's negative and we know it's not 0. So the first guess is really it's going to be like less than 0. But perhaps there is there's a lower bound. Perhaps there is the like the largest negative number. Well, let's look at the bottom here and think about if I want to get like the biggest negative value, I would need the denominator to be as small as possible, because if you divide by a smaller number, you get a bigger value. So what's the smallest this could possibly be? Well, x squared is always positive, so the smallest it could be is 0, and that would leave us 1 on the bottom, which will give us -5 over 1, which gives us -5. So that's the smallest it could possibly be. Like the biggest negative number it could be is -5, and it can equal that. So it looks like it's trapped in between -5 and 0.
Gang. Okay, I understand what range is now. So I guess that's program. Range is the range of values that it could possibly be. Range is range. What do you do? Historical. Even the range is range. Even the range is range, right? Like, what does that mean? You get what I'm trying to say? Like, range is the biggest and smallest value. So it has to be smaller than 0. But what's the smallest value of this? It's the smallest value it could possibly be. I have no idea. Can't x just be anything? Can you do this with the calculator? I feel like the calculator would be really helpful. So -5 over 6, and let's say it's big number squared plus 1. That doesn't look like it's stuck to -5 to me. Yeah, no, I don't understand it. I don't understand range.
So that is our range. Perfect. Okay, let's do question D now. It says find the range of values of k is a constant, for which the equation f of x equals h of x, which is this guy, has no real solutions. Okay, so I'm thinking no real solutions means we're going to have to use the discriminant, and it's asking us to solve f of x.
How long we got? We got like 3 hours now. I made such a good start. We're lagging. Queen is fading. It's fading fast. Oh. Bum, 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 bum. Do anything we need. Get a game of chess. We'll be playing 10 minutes. Because I'm pretty sure it's, yeah, I'm playing 11:77, so good. It's so annoying. Like, I'm playing all these people, right? That are trash. Like, look, he's confused. He's like, do I tank? Do I not? That is the question. Like, broski. This could get good, actually. Uh-oh. Okay. This cannot get good anymore. Okay, I'm gonna take like this. And now I'm basically forced to take like this. I'm basically forced to do that. I should have kicked. Yeah, and I'm forced to do this. Oh, don't do it again. Oh, that'd be such a bummer. Oh no. Oh no. Oh no. Oh no. Okay, we're actually gonna have to do this now. Because I can't break this pawn structure, I realized. Yeah. No. I have to hide now. That just loses it on the spot, bro. Oh man, this is horror. I'm not supposed to meet up in Barbados. Shut it. Yeah. Mm. Do it to like this. Let's to like this. That's dangerous. We have to like this. To like this. Oh no, but that's bad. Oh, good. I'm still cooked. Where's he trying to go? Okay. Yeah. That might will give me time. But I can't put it this way. I can. They're not connected. But then if she checks me like okay, this is fine. This is fine. It doesn't matter which. It doesn't matter which. Because you don't actually have yeah, you can't do that. You can get a trade, and that's it. Either way, I'm about to castle basically, so yeah, what did you do in your trade, bro? Okay. Um, I feel like I win now. Do a trade. Okay, nice problem. Nice problem. Uh, um, hmm. I have check. Oh, I could just do this. I could do this. I give a check like here. Just see what they do. You know what I mean? I'd imagine this is what's coming. It's quite dangerous. This, that. So I'm gonna just trade it off. Makes sense to you. Oh, okay. You can do that too, I guess. I mean, this is just losing. This is 100% losing. No doubt about it. See, it's a 177 opponent. They don't know how to actually play. Like, they're not actually good. Like, so. I don't know. I have many options here. I got options. Bad news whip just hopped in. So he can't take. We can, technically. Either way, you're in trouble. And I got tactics over here. Why? I got tactics, man. I could just slide this off and it'd be a tactic, bro. You get what I'm trying to say? So Loki, genuinely, Loki genuinely. Loki genuinely though. He's gonna blunder. I can smell it, bro. He's gonna take. This is bad for you. I need less rooks on the board. Let's do more favors. Oh, oh, that's sick. Surely he's trifling. No, he's trifling. It's game. Oh wait. Let me see. This. No, wait, what? This. No, wait. Yeah, you can't go there. So it'll just be this. If I slide, and well, they're not even touching anymore. So what are we talking about? What are we talking about? What are we talking about? What are we actually talking about? What are we actually? There's so many. Oh my days. There's so many tactics, bro. So many tactics. That's mate. What else is gonna be mate? There's gonna be so many mates. Nice. You proud of that? You proud of it? Are you proud of it? Let's probably do something like this. It's tough. I don't really have anything. What do you say? I said you haven't said anything. I don't know, this is frustrating. Can I hit this? Yeah, watch this, 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 watch this. Watch this. Okay, and he's gonna check me, and he's not gonna go back to the same spot. He's not gonna go back to the same spot. Right? He will not go to the same spot. He'll take. If he takes, actually, that's bad. But he wants to check. He wants to check, right? You want to check? There's a check. Free check. Free check and take this one. Yeah, yeah, yeah. That's what you want to do. Yeah, yeah, yeah. Good boy, good boy, good boy. And I'll take this one. Yeah. Oh man, that's funny. Man, that is absolutely hilarious. Okay, it's this sack, right? And then this, and then this, and then this, and then this, and then this. It's just this knight. I am the knight in shining armor in your movie. It's this knight, bro. Covered in the square. I can't get in. Okay, okay, okay. How do I get rid of the knight? Legit. Legit though, how do I get rid of the knight? Do this, this, and then, yeah, 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 yeah. It is, it is, it is, it is. Okay, if I do this, there's no mate still. Okay, you just have to hold his horses. Okay, wait, but if I do that, hold on. If I do this, and then I get checked. Wait, I get checked. I'll have to block the check with my rook. Okay, cool. I have to block the check, whatever check it is. I have to block it with my rook. Which is unfortunate. But it's the price you have to pay for greatness. And then I have it all coming. Yeah, so good. It's the price you have to pay for greatness. This is the price that you have to pay for greatness. Oh, you messed up. You messed up, bro. You messed up, bro. Why am I pinned? No. No. I lost to this guy. Are we serious, bro?